Hi future doctors, welcome to the next class. In this class we will see pressure energy. What is this pressure energy? So if you are taking a beaker, if you fill liquid, so whenever you are filling liquid, you have closed this wall with a movable piston. This is a movable piston, so which is having length x or L. Area of cross section of this one is going to be A. So whenever you are applying force on this piston, it will be here. Otherwise, whenever you leave your hand, this piston is going to move. Liquid is going to make this piston to move up to here, or it will be coming out of this. Why? Because the flowing liquid will be having some amount of energy it is going to do. So if this is the liquid means here, this liquid is going to apply some amount of pressure force on this. So if this cap is loose means it will be coming outside. So it is doing some amount of work done. Every energy we will say, we will get from work done on this. Say potential energy you got from work done equation. So mg, kinetic energy also, work done equation. Strain energy also of force into elongation. Every energy you will get from work done. Here also pressure energy also you will get from work done. Force into displacement. Both force and displacement in same direction, cos 0, 1. So how much force is going to be applied? What is the displacement means? X. What is the force means? Pressure is equal to force by area. Then force is pressure into area into x. Area into distance gives volume. So pressure into volume. Product of pressure and volume is called pressure energy. So pressure energy is equal to PV. Pressure into volume gives pressure energy for it. What is AV in previous equation of continuity, product of A and V. So that is also going to give one physical quantity. What is the physical quantity also we will see. This is the pressure energy, product of pressure and volume. Next, pressure energy per unit volume they will say. This word you will use in Bernoulli's principle. Pressure energy per unit volume. That is nothing but PV by V. So VV will be cancelled. So pressure energy per unit volume is equal to pressure. So pressure another name in flashback. Pressure energy per unit volume. So P pressure can be written, represented as pressure energy per unit volume also. Next, what is this AV? How much volume of liquid is going to be coming? The amount of volume of liquid per unit time. Same like that, the amount of mass of liquid per unit time. So again you are getting this one according to equation of continuity. If you are taking two different vessels, so this is half liter bottle. In this some amount of water is liquid is going to be present. So just I poured like this by removing cap. So this volume of liquid is going to be coming half liter volume. So same water if I am taking this is a liter bottle. Same cap I remove means if I pour like this, so the amount of volume of liquid, it is having different mass. That bottle is having different mass. So 1 liter bottle is having more mass. How much mass of liquid? How much mass of liquid per unit time? How much volume of liquid per unit time? Half liter bottle volume is less. So 1 liter bottle volume is more. How much volume of liquid is passing per unit time means? That one only we will get volume can be written as area into distance by time. So what is distance by time we will call? That is only AV. So according to AV we are saying equation of continuity. Now we are saying AV, product of area and velocity gives volume rate of flow. In some books they will represent this is with capital Q. How much volume of liquid per unit time? This is how much mass of liquid per unit time. So you have seen 1 liter bottle, half liter bottle, in which more mass is going to be available. 1 liter bottle you will be having more mass. How much mass means? Mass can be written as density into volume. Again volume by time, we can write it as AV. So rho AV. So rho AV gives mass per unit time. How much mass of liquid per unit time? AV gives how much volume of liquid per unit time. PV gives, that is going to be pressure energy. Only P gives pressure energy per unit volume. So these are very, very important equations whenever they are going to ask the problems. So if area of cross section is going to be changed, the amount of volume of liquid is going to be changed. So let us assume this is the water bottle. So if you have seen here, two area of cross sections are there. This is one and this is top one is one. So this is having less area of cross section. This is having more area of cross section. If you pour water like this, volume coming from this area is going to be less. Therefore, it is depending on area of cross section also. Therefore, they will be representing pi r square. Radius is doubled. What happens to volume of liquid or rate of flow? Volume rate of flow they are going to say. This is about pressure energy and volume of liquid per unit time, volume rate of flow and mass per unit time. Next, so within this tube of flow, whenever liquid is flowing, so because of velocity is going to gain kinetic energy. What is the kinetic energy per unit volume? Kinetic energy per unit volume of mv square by v. So mass per unit volume we will call density. Therefore of rho v square. So kinetic energy per unit volume. So because in this tube of flow, liquid is going to be flowing means it is having some velocity, it is having potential energy from ground and it is having pressure energy. Total three energies we are going to calculate. Pressure energy, kinetic energy, another one is if it is having at some height, potential energy, that is going to be mgh, potential energy per unit volume. Again mass by volume we can write it as density, rho g h. So pressure energy per unit volume is P. Kinetic energy per unit volume is half rho v square. So potential energy per unit volume is rho g h. Sum of all these P plus rho g h plus half rho v square is always going to be constant. Who said this? This is only we are calling it as Bernoulli's principle. According to Bernoulli's principle, the sum of pressure energy per unit volume, potential energy per unit volume, kinetic energy per unit volume is always going to be constant. So what is the significance of Bernoulli's principle? So P, what we said, not pressure. What we said? Pressure energy per unit volume or pressure. Pressure also you can say, but in this you have to say pressure energy per unit volume. Rho g h you said potential energy per unit volume. Half rho v square you said kinetic energy per unit volume. Now what is the significance means? All these are energies: pressure energy, potential energy, kinetic energy. Therefore, law of conservation of energy. So what is the significance of Bernoulli's principle means? Law of conservation of energy. What is the significance of equation of continuity means? Law of conservation of mass. So this is the important introduction for Bernoulli's principle. So later we will see how it is going to be applied, different equations, how we are going to get, we will see. So in this you should remember mainly this pressure energy equation, pressure energy per unit volume and this AV. So AV and rho AV. Okay. So AV equation of continuity also if AV equal to constant. So AV is nothing but volume of liquid coming outside of the where tube. Next, rho AV, the mass of liquid coming outside of the tube. Isn't it? Mass per unit time, volume per unit time. So try to remember this, then we can do problems very easily. Thank you.